Our first episode of, how do I do that again? GIS for the geoengineer. So we'll go ahead and get right into it. You have the software. Go ahead and open up a map and start a blank map. Now the first thing you want to do, generally, unless you know exactly what you're doing, is you want to add a base map. So go ahead and click this Add Data button and then Add Base Map. This will bring up a screen that'll give you a lot of options. For now, let's just use the imagery with labels. And it's one of the complaints that comes up with the old version is that it's quite slow, which can sometimes be true. And you'll want to zoom in to your study area. Now, one of the things you can do to speed this up is go ahead and take the references off if you chose this map with labels, and then right-click the base map, go to Properties, and under here where it says Scale Range, I don't need to have the entire planet drawn on my screen. So I'm just going to say when I zoom out after, say, 1 to 100,000, the map just disappears. So the rest of the Earth is now no longer being drawn on my computer. When I zoom out, it disappears. And zoom in, shows up again. That'll actually help processing significantly, since the older version that we're using right now generally only uses one CPU core unless it's a specialized tool in which it uses more. But the next thing we're going to do is we are going to grab a DEM. That is short for Digital Elevation Model. And what that is a rasterized image. And what that is it's an image where every single pixel or cell has some sort of numerical value associated with it that means something. So in a DEM, each cell represents an elevation. This cell is at 6,000 feet, this one's at 6,010, and you get enough of those together and you get a map. So for this, the place you want to go to is the National Map Inventory at this website. And what you're going to want to do is zoom in to wherever you're looking for your DEM, which in our case is right around here, around Green Mountain. And we're going to go over to elevation source data. Nope, elevation products, not the source data. That's if you want to do some really crazy stuff that we don't want to do. So go to elevation source data and you'll get a list of sizes. Now we're looking for lidar, which is available, especially since we're in a major metropolitan area. So lidar is typically a 1 meter DEM, and the 1 meter is the resolution, meaning each pixel is 1 meter by 1 meter, whereas 5 meters by 5 meters. So as you go to worse resolution, higher numbers, you get a lot less information about what's happening. So you'll click that, then you'll click, I like to do box point and say, we want the lidar in this area. Click find products, and then one will show up. Next thing you want to do is click the footprint to make sure it's in the correct area. And it is. So then you can go ahead and download that right there. But we already have that, so we'll go back to the map and we'll go to our Add Data button again. And actually, before you add data, you have to, this is one of the things that's improved in the newer versions, but you have to add a connection. Now, a folder connection tells the software what folders it can look at when you want to pull data in. So you would click connect to folder, and then you'd navigate to your folder, and then you click OK. And then it will show up in the available folders. So we'll go ahead and add the DEM, and for this, it is under this .img file. And this is what it looks like. It's kind of a grayscale map, and you can sort of make out features, but that's just a base map. We're not don't actually want to look at that. But before you get working with this and try to do some analysis on it, you're going to want to check out what's called the metadata. So when you download your DEM from that website, you're going to get a zip file that just has a whole bunch of stuff in there. So you're going to have what's called a data dictionary, which is this fun 37-page document that if you really have a lot of free time or really want to know exactly what you're doing, you can go ahead and read through. But this just gives you an explanation of all the terms that are used in the metadata. And what we are looking for is really this text file right here. Now what you want to look at is two things. You want to make sure the resolution of this file is what you think it is, and you want to see what coordinate system it is. So we'll scroll down, and right here we have Universal Transverse Mercator UTM Zone number 13. Now that's good. That's a grid coordinate system, meaning it's an image of the Earth that is then projected into a grid. And then below that we see our resolution is 1 meter. So that's everything we need to know. Now what I want to do with this DEM first is I want to create a tool that will help me visualize. So that's where you create something called a hillshade. Now the best way to find this, if you don't know exactly where to look for it in your toolbox, is just to hit the search function. And type in hillshade. Then you want to go to spatial analysis, input your raster. Now that's the DEM that we talked about. And then you can leave these angles default. That's like the angle of the lighting on the hillshade. And then the Z factor. Now this is, since we are using UTM, we don't need to worry about this. It's just 1. But if you were using a non-projected coordinate system where the map was in, degrees, minutes, seconds, you would have to use some sort of factor depending at what you were looking at and where it was on Earth. So we'll just go ahead and click OK. Okay, so once that's finished, you get this gray 3D representation of what the Earth looks like from the lidar. And when you zoom in really far, you can start to see features like this trail. Now, you can see that on the world map, but there's also some stuff that the lidar reveals that you can't see from just aerial imagery. Like you can see the depth of this scarp and these smaller landslides all around it, and just all sorts of land features that don't show on an aerial image because you have trees in the way. This debris flow fan has trees all over it, but with the lidar it cuts straight through it, so it allows you to see a lot of extra stuff. Now suppose you don't need this whole file. It's just too much information, and it's making your computer slow, it's not working right. You just want to narrow your focus. So you can actually clip out just the part you want and keep your file smaller. Now to do that, you're going to need to create what's called a shapefile. And a shapefile in GIS is kind of just what it sounds. It's a file with a bunch of shapes in it. I mean, it could be squares, rectangles, points, lines, anything along that. So what you do is you'll click the catalog button over here on the side, and you'll want to navigate to where you want to create this shapefile. So go into my test folder, click the shapefiles, right click and go new, and then go down to shapefile. Now I want to create a square that'll be my study area, and I want to get rid of everything else. So I'll just label this extent, and I'm going to use a polygon, so like I said, square. And then for coordinate system, we want to tell it, what coordinates we're using. Otherwise, it'll use the map defaults, which usually doesn't make a big difference, but there might be like a meter off here or there. I'm going to use the same coordinate system as our DEM, which is this UTM zone 13 north. Click OK, and then that's done. You'll see over here that it is added to our layer list. Now, the next thing I have to do is go to the editor, start editing, click what I want to edit, click OK, let it think. Okay, then get rid of the search bar. You'll click on this tab right here, Create Features. Click the extent, then we'll go down to Construction Tools, click Rectangle. I'm going to zoom out a little bit. And when you're zooming or need to look around for another spot, the best way to pan is to hold the C key and move with your mouse. And on another note, if you're using this on a laptop and you don't have a mouse, that's wrong. You need to get a mouse or you're going to have a really bad time. So then I'll just click somewhere, drag, click again, drag, and there we go. I got a pink rectangle. Click Save Edits, click Stop Editing, get rid of that. And then that is going to be the area I'm going to look at, but not quite yet. First, I'm going to double click there and click this hollow feature. So I get rid of the pink, it's just the outside line now. And I'm going to go back to the search and search for a tool called Clip. Now, some of these tools, there's a lot of different versions that do different things for different type of files. But the one we want right now is Clip Data Management. Cuts out a portion of raster. Great, that's what I want to do. Input your raster. Like I said, this is not your hillshade that we just made. Actually, yeah, let's cut the hillshade. And then your output extent, which is what we just made. And then just, unless you know what you're doing, just ignore that part and click OK. You'll get another file made, and when we turn off the other one over there, you see that what we're left with is this clipped value. And everything on here is exactly the same. We just made it smaller and easier for the program to manage. Okay, now that we got our hillshade done, it's time to start analyzing it and looking for some geological features we can map. With that smaller file, you can now zoom and pan around at a much quicker pace. It'll help accelerate your workflow. So let's just go into this area, for example. We're going to go back to our catalog, shape files, create another polygon shape file, and we're probably looking at a landslide, so let's call this landslides. And then we're going to make sure to update our spatial reference. Now, you will probably not have a favorite zone, so if you don't know what zone to use, you can go to Import, and you can click on the DEM that you've already added, and then it'll automatically add this favorite UTM zone 13 north. You can also scroll through the entire list and pick it yourself manually. Okay, so this is similar to making the extent. We go back into the editor and we start editing our extent. Click that, then go down here and click polygon. Now, there's a couple of ways you can draw on this. You can just click like this. You can add some arcs by clicking once. And then clicking again. So one click, then bend it. You can switch back to straight mode. You can do all sorts of different operations. And this works if you have some very perfect features, or just very smooth changes. But that's actually probably most of the time not the quickest way. And this may be inelegant, but it works very well. You just click and start clicking really fast, and just follow it all the way around. There you go, there's your landslide. Now if we wanted to, we could go over here to attributes and call this ID number 1. It's automatically 0, but let's just call it 1 just for fun. And then click Save Edits, and then click Stop Editing. There we go, we've mapped a landslide. Now maybe we want to add more details to our shapefile. So you go over here, you right click it, you click Open Attribute Table, and you'll see that this is our shape 1, and there's no information there. It's ID 1 and it's a polygon. Helpful, right? So you can add a field and call it whatever you want. You could say, oh, this is a type field, and we don't want numbers, we want words, so we want to go down to text. And yeah, 50 sounds good. And then if you open up another editing session again, you open up the right one, you can actually type in this box for later use, like stop editing, add a field, and we're going to call this one area. Now with the area, we can right click, go to calculate geometry, click yes and ignore that, and then there'll be several options. So I don't care too much about the centroid or the perimeter, but I do want to know the area of this polygon, and I want it in square meters. And there it is, 8,167 square meters. The annoying thing is it doesn't always tell you what the units are, so you need to make sure that, oh, look, down here in the bottom right, okay, the coordinates are in meters, so anything I make should also be in meters. And that's that for drawing. Next, we're going to make a slope map. And this is just a colorful map where a color represents the slope of the hill at that point. So we'll go ahead and just zoom out so we can see everything better. We're going to go back to our good friend Clip, Data Management, and this time we are going to clip the original lidar. So that's this one right there. And we're going to use that same extent. Now we're doing this because it'll speed things up. If it's a smaller file, when we process the slope map, it'll go a lot quicker. So clip, clip, clip. Probably cut this out in editing. There we go. Now I'm going to go back to my search, and I'm going to type in slope. I'll go to that one, the spatial analyst, input raster, and I'm going to go to that one. And here's another thing I didn't mention before. Be careful about where you're putting your files, because by default it'll go into something called a geodatabase. Don't really worry about what that is. It is just basically one file that holds all your other files. When you create a shape file, it's not one file, it's actually 4 or 5. So this just helps organize it. But you'll need to find your stuff later. So if you want it to go into a specific folder, I mean, you just open this up and, slope, save. No problem. Z factor, since our DEM was in meters, don't worry about that. 1 is correct. And then click OK. There we go. We now have a very colorful map of the slope. As you might guess, red is not good. Or it is if you're looking for high slopes, but it shows areas of high slope, and that's over here on the left. And those numbers are actually degrees, so we can see that kind of orange starts at, like reddish orange is 28, and that it goes up to 81. So somewhere on this map, not necessarily here or here or here, there's an 81-degree slope, which is essentially a cliff. Now, if you want to look at something very specifically, you're going to need to use what's called the pixel inspector. So I'm going to go to customize mode, and I'm going to create a new toolbar. And there's a lot of reasons you should do this. I don't want to get into it, but just create a new toolbar. And yeah, sure, custom one. And then it popped up right over here on the left. I want to go to commands. Just type in pixel, there's pixel inspector, drag it into the toolbar, close. There we go. Now this is kind of a funky way it works, but the size of this window determines the size of the actual tool. So if you zoom in, you can see the grid boxes. Make it like that, we get a really big one. But you know, I really only want to know, you know, maybe a 3x3 grid. So I'll just shrink it like that. And then when I click and hold and move it around, we can see the slope values at each one of those points. And so if you're doing some sort of hazard susceptibility map, you know, the slope is really important. If you took a soil sample at a specific spot, you might want to say, hey, the slope there is 31.2 degrees. Like I said, that'll help add value to the work you do. Okay, on to the final topic for this video, the dreaded georeferencing. Now what that means, georeferencing is this act of taking, say, an image that is just an image. There is nothing special about it other than that it's an image, and cramming a bunch of coordinates on it. So when you look at it on a map, that image is exactly where it's supposed to be. Now, if you're lucky, you can already find georeferenced materials. Like if we use the USGS's map program, we zoom into our area of interest and we find a map and go, yeah, this one's awesome, I want it. Go ahead and click it and go to download. It's going to give you some options. Now for our purposes, the most important one we have is compressed GeoTIFF. And what that means is they've already put coordinates into this map. The JPG, the regular graphic, and the PDF don't. It's just a picture of this large geological map. The Earth KMZ also has similar functions. So when we go back here and we click our Add Data button and we go to that map we just downloaded, and we add it in, it's going to have this conflict warning because its coordinates are a little bit different than the coordinates I'm using already. Like I said, small scale, maybe a meter difference, not much. Shouldn't be, it's not a big concern. Now let's see where it ended up. We'll turn back on our base map and then you can kind of turn it off and on to see where it is, or for a better view, go to Effects, which I already have opened, and then select the image click this button. This is a transparency toggle. We can actually make this layer transparent. When we zoom in, we can see that this map we just downloaded is georeferenced correctly, and everything is where we expected it to be. And that's great. They did it for us. But some of the times, somebody, for some reason, no idea why, is going to give you some sort of map, maybe a contour map, and it's going to be in a PDF, and it's going to have absolutely no coordinate data, and you're just going to have to pretty much guess where it goes. So we're going to georeference it to take away that guesswork and make our lives easier when we're making professional digital maps. So go ahead and turn this off, and then we're going to add our ungeoreferenced image. It's called Y. And you're going to get this error because it doesn't know where to put it. This map, it just doesn't have coordinates in it yet, and that's normal. So don't be worried, just click OK. And then you're going to look, and you're not going to see it. It's just not going to show up because for some reason Esri decided that if it didn't know where your picture was supposed to go, it should just throw it in the ocean. And I literally mean ocean. So here's a picture of what I just added. And you can see the white background, but let me turn on the base map. And then let's zoom out. Okay, yeah, so we're directly in the center of the ocean off Africa. Awesome. So we need to fix that. So I'd recommend for now turning off the base map. Let's turn back on our hillshade, because this is how we're going to georeference it. And we're going to do, there's two ways to georeference. So we need to go find our picture in the middle of the ocean. I don't want to zoom around the entire planet looking for it. So you just hit zoom to layer, and I'll take us right to it. Now open up the georeferencing toolbar. You do that by right-clicking on the open space, by the way. Okay, there's georeferencing. So the first way we're going to do it is the easiest, but sometimes less accurate way. Make sure that y.png is selected, and then click this add control point. That's a really simple procedure. So you want to look for features that are easy to tag. So you're going to click somewhere, like say the inside of this bend on this trail, and then you're going to mouse over and zoom to your layer of your hillshade. And we're going to zoom back in, find that point, and then we're going to click again, and there's the map. Look at that. Pretty easy. But that was just one point. There's still a variety of stretching or rotation you might have to do on the image to make it fit. So we're going to go up to our effects here, select our image, and we want to make this transparent because we need to see. So maybe do like 60+%. So then I want to look for other features I can find. So here is our image, and that correlates to the lidar right here. So we'll click on the image first again, and then we'll click right there, and then there we go. That's georeferenced. Click update georeferencing, go ahead and close it, and you're done. We now have an image that is in the correct location and that we can work with now. Now then there's the other way to do this. And like I said, it's the more accurate way, but we'll go back to our georeferencing toolbox and we'll click this view link table. And there is none because I need to redo this. Okay, so for the a little bit more difficult, more accurate, sometimes method of doing this. We're going to enter in coordinates directly to those points. So looking at our map, we're going to have to use this information tool thing. And we're going to click right where we want it to go. Now we'll get a set of coordinates right here, and this is UTM, so it's meters. But if we wanted something else like, I don't know, decimal degrees, we could do that. But we don't, so we're not going to. Now we're going to go to our Y copy here, zoom to the ocean, and the same process before. Make sure you got the right one selected. Now click once, don't move the mouse, and then click again. Then find your other spot, click once, click again. What we essentially told it was drag this point to this point, but we didn't move, so nothing happened. But it creates these points that we can now edit. Now I have taken the liberty of getting these coordinates in meters. So we'll just go ahead and copy that, Y map, because these are XY coordinates. Wrong thing. In the background, you'll see it doing stuff. As I enter these coordinates in one by one, it's stretching and twisting all over the place. There we go. Okay, done. Hit save. No, not hit save. Let's go to zoom to layer, and there it is. Just exactly where we want it. This looks really good if you have a geological map that maybe it's a scan and you need to georeference it, because they'll have coordinates in the corners and all over the map. So that'll allow you to get really good georeferencing. And then go ahead and hit update georeferencing. And that's it. Questions, comments, leave them down below. And I'll see you for the next episode of Why Do We Have to Keep Doing This?